Alright, let's get stuck into it. Okay, so this morning we will be going over the first half of Chapter 4 in the Python Essentials. So basically today we'll be looking at function results and scope. So in the last session we did the lovely logical and bitwise operations, followed by lists and list processing and that lovely list within lists within lists. So a function can either be a built-in core function of Python itself or one of its modules. Today we'll be looking at writing our own functions, which is basically defining a set of code you want to execute multiple times throughout your program. So this is an efficient way of programming because all what you have to do after defining the function is to execute it. Saves a lot of repetition. Now, one of the things you'll get used to if you decide to choose a career in code is that projects get broken up into working modules. Now, these can be based on function or making it easier to read. Basically, you get chunks of code. Now, this can enable things to progress faster and provide benefits in that you've got isolated testing of a function, so you're not having to go through the entire program. The other item there is generally it's not a single developer working on a project. So by breaking it up into parts, you can assign it to different people. And then at the end, we come to packaging, where we bring all those separate items back in to form the final program. So this enables us, if we've created a nice modular system, is if we want to update something, we can just update the module, which could change the entire functionality of the module, but doesn't change the final product. So it allows us to increase our scalability, because once we create a module, we can also recreate it in multiple places. So let's start off by defining our function, and we use the def command for this. So def, the function name, any parameters within your parenthesis, followed by a colon, and then tabbed under that is all your commands that you want to be executed as part of your function. So the naming convention for a function is basically the same as the variable names. So in other words, it's got to start with a character, it's got to be upper and lower case, numbers and underscores. Each function has to have a pair of parentheses for your parameters to be nestled in. So pretty much the same rules as when we're defining a method and that inside. So the if loop, for example. So you got your defining statement on the top, and then all of your grouped executables underneath. And once they're finished, it goes back to the rest of the body. So one of the very first basic programs we did was a print command, which was print his. So instead of that, we're going to be a little bit more polite and define a message function, which is going to print hello. And then you just call the message or invoke the message function, and it'll execute that. So it's quite a quick and easy one to explore. Yeah, I know, you've all gone off and done it. So what we can do is expand on those basic functions. So here, same basic function, but we're adding a parameter, which is name, and then we're going to define name as an input. So we're going to get somebody to enter some information, and then we're going to call the function and provide the argument. So the rule is, before you can invoke it, it's got to be defined. So it doesn't matter how far above your coding that the function has been defined, but it must be defined before you can invoke it. Remember, Python reads left to right, top down. So if we want to use arguments within our functions, we have to define them. So we define them within the parenthesis, and what we can do is give them any name, even names that are used elsewhere in the main code. So this way you can absorb them in, but generally speaking, when you're defining parameters, they only work within the function. You then define the value of that parameter at the time of its execution. You can define default values. That is possible. But generally, you go through and define them. Now, they do normally follow a positional rule. As we've discussed previously, you go in the order that they're defined. But when you're invoking them and you use the named parameters, so first name equals, for this example, the order will not be as critical, because you can then clearly see what the values are, so you can mix them up. And if you have defaults defined in the function, so here we have last name equals Smith, so that's a default that's been defined in the parameters statement of the function. That means we can miss that parameter when we invoke it. Now, we can do two things. We can perform an effect, which happens when we invoke the print function, for example. It prints something on the console screen. Or we can actually return a value that is to be used outside of the function. If we intend on doing that, we need to use the return keyword, and this will terminate the function's execution, so be careful where you place this. So here we're defining Happy New Year and doing a bit of a countdown. And then we've got the good old if statement and termination function. So if it's not wishes, so it isn't true, we're going to terminate and then jump up. So as I said, the function's defined first, invoke the function, and then the rest of your program. Give it a try. Play with changing wishes, values, that sort of thing. See how the parameters defined in these examples affect the outcome if they're changed. Excuse me. So here we're going to be very boring. Get it? Definition boring function. So we're just returning a value of 1, 2, 3. X equals the function. So when we print X, we're just returning the value. Now, you wouldn't define a function with just a static variable like that. You might as well just use a straight variable equals. But it's just providing an example of how the return function will provide a value outside of the function. Alright, next function, none keyword. So be careful where you use this one, because it can cause errors. So when you're assigning or defining a variable, we can use it there. safely. And you can also use it safely when you're using it as part of a comparison. So value equals none, and then conditional, if value equals none, then print, sorry, we don't have value. Pretty rude statement in and of itself. Can you define lists as a function? Yes. But you've got to make sure the elements are valid for the list. So here we're going to define a list and create a little loop which returns a sliding value and inserts it as an element. Is that the way it works? No, you're all asleep. Okay. So, what are we doing? We're defining the parameters when we invoke the list. Alright, so it's going to go through each element and sum them up.
I just don't understand the logic of what's going on there. It's just very confusing.
Okay, so list the sum, and we're going to have a list parameter, and we're saying s equals 0 to start the variable. And what we're saying is for each element in the list, we're going to add it to s. And then
so is S basically the index?
S is the sum of all the values in the list.
Right, okay. Alright. Okay.
It's a variable. Okay, so what we're doing when we're invoking the function list sum is we're providing the argument, the list, values. And what it's doing is for each element, it's going to add it to S. So 2 to S. S starts at 0. So first time it runs through, it adds 2. Then it adds 5. Then adds the next element. So on and so forth. Until all the elements within the defined list are added together. And then returns the sum.
Right, that makes a lot more sense. Thanks for that.
That's right. So, can we create a list as the result of a function? Of course we can. All what we have to do is return it. So in this one, we're defining strange list fun with a parameter of n. So we have, if we skip to the bottom, when we invoke the function, n equals 5. So when invoking the function, we've provided the appropriate argument. So strange list is defined and is empty. So this is a list with no elements. Then we're creating a for loop for n times, so we're 0 to 5. And we're going to insert the 0, so we're inserting at 0 the value of I. So for every round of the loop, we're inserting a value into the list and then returning the compiled list as the result of the function, which would give you a list consisting of numbers. So scope is the extent that the name is recognized in the program. So under general rules, any variables used inside a function are not recognized external to the function. So you can reuse variable names defined in different functions because they have no global recognition. So they're not recognized by the main body of the program because they're only used within the function call itself. This can be a problem because you might have that defined in the main program. If you have an instance where you have a variable same name in the main program as that one defined within your function, then it will use as a priority the one that is defined in the function when you when you call the function. So the scope, put the global command in, and we can change where the variables have scope. So we've put global in front of the variable names. What we're doing is we're going to say this variable can be used outside of the function. So to give you an idea, we're defining a global variable called var, giving the variable a value and printing it as a function. So when we are outside, we have a variable of the same name, but that is equal to 1. Then we call the function. So we are defining a new value for that variable as part of the function. So when we go to print var, it will now equal 2 because it's a global variable. So as we've set it effectively after, alright, this setting of var equals 2 doesn't occur here. It occurs when we call the function. So as you know, when we define the value of a variable, it equals the last time we defined it. So by invoking the function and changing the value within a global variable as part of that function, that's the current value. Just be careful using global variables inside lists, because remember, lists actually exist in a memory location. So what happens is you modify the list globally regardless. Alright, so the sections... Oh, I forgot to modify that. It's going to be section... So this is part 1. You've got some labs as part of this, which will take a bit of time to work your way through. But that's where we're going to call it for today. Okay, so got a bit to work on. So it's a bit to get through. Defining functions is pretty straightforward, especially as we've covered C# first, so you know about defining functions, methods, and producing a result from that. And the scope is just telling you how to bring, for example, the variables, instead of being contained within the function, you can have them affect variables in the main program. Alright.